Good afternoon, students. It's Mrs. Cindy, and I am going to talk to you about adding and subtracting mixed numbers today. We're going to go through 4 types of situations that you could encounter on questions with adding and subtracting mixed numbers. So let's go through each one kind of methodically, and then you can get to practicing, and I can help you as class goes on. So the way that this is going to work. The way that this is going to work is, let's say that we are given a whole number and a fraction. Okay, so the whole number, let's say, is 3 minus 7 twelfths. Okay, 3 minus 7 twelfths. So we want to kind of figure out a way to rename this 3 to turn it into something that's a little bit more usable. Okay, so let's rename, the integer as a mixed fraction. Okay, so what we'll do is we'll say that 3 is really 2 plus 1, and 1 is really any fraction, okay, as long as the denominator and the numerator are the same, right? 7 divided by 12 is not 1, but 12 divided by 12 is indeed 1. So what we could do is we could say that 3 is really 2 plus 1, or 3 is really 2 plus the fraction 12 over 12. Now suddenly we have a problem that we can solve. We have 2 and 12 twelfths minus 7 twelfths. And we can do this problem. 12 minus 7, so this would really kind of look like the way that you would be doing the math, is 12 minus 7 all over 12. And this 2 is going to remain right there, right? So this would really be 2 and 5 twelfths. And of course, when we write a final fraction, we want to think, do I have to reduce this? And the answer here is no, I don't need to reduce this number. Okay, so this would be one example, and of course circle your answer, show your work as you walk through it. But that would be an example of when you were given a whole number and you were subtracting a fraction. Okay, as you would regroup or rename that fraction, that integer first. Okay, type 2. What would happen if we have, I'll change colors today, if we have a whole number and we're subtracting a mixed number? Okay, so let's use the example of 9 minus, subtract, 7 and 4 ninths. Okay, the answer is going to be around 2, right? 9 minus 7 is around 2. So we know we're going to get an answer that's around 2, and that's always an important thing to do when you're working with fractions, is to really estimate, because you can get a ballpark of what your answer should be looking like, and sometimes we can really get numbers that are off. So what we want to do here is, again, we want to rename our whole number right here, our integer, to be 9 is really equal to 8 plus 1, which is really equal to 8 plus, and the fraction here is 4 ninths. So let's turn it into 8 plus 9 ninths. So that 1 is really going to be this fraction of 9 ninths. So then we have a problem. We have 8 and 9 ninths, subtract 7 and 4 ninths. And so you can do the math in 2 kind of steps. 8 minus 7 is 1, and then whatever's going to remain after you subtract the 9 from 4, I'm sorry, the 4 from 9, and you will get from this 5 ninths. And then you put the 2 together, and so it would be 1 and 5 ninths. Again, do I have to reduce? The answer again is no, conveniently, so you don't have to reduce, and so you would get that answer. Okay, so those are the first 2 types, okay, of problems. Let's look at some other examples. Type 3 is going to ask us to look at a mixed number subtracting a fraction. Okay, so in this example, we are going to have, for example, we're going to have 1 and 3 tenths, and we are going to subtract a negative 4/5. Okay, so first off, I'd like you to remember our whole scheme of slash slash. So we're actually being asked to add 1 3/10 to 4/5. And so now it comes down to a pretty straightforward problem. We do need to find a nice least common denominator. We need to find a common denominator here. 10 goes into 10. 5 also goes into 10. So if we bump these two up, 4/5 times 2 times 2, that will get us to 8/10. And then we have a common denominator. So then we have 1 3/10 plus 8/10, which means that we're going to have 1 plus 3 plus 8 over 10. So that means that we're going to have 1 11/10. Am I allowed to have that? The answer is no. That's an improper fraction within a mixed number. Totally unacceptable. So what we do is we turn this this improper fraction into a mixed number. So we're going to do 11 divided by 10. Goes in once. We have 1/10 remaining. So we had 1 plus 11/10, which is now, we've discovered, really equal to 1 plus 1 1/10, which would be equal to 2 1/10. And that is my answer. And when we think about these two, this is pretty close to 1. This is pretty close to 1. 1 plus 1 is going to give us a little bit around 2. And that works out. That checks out. I'd like to do another example here to show us what happens, what other kind of scenarios we could have. So another example would be something like if I have 7 1/4 and I'm subtracting 3/4. So I've taken care of my common denominators. That's good. But can you subtract 1/4 from 3/4? And the answer is no, you cannot. So what we're going to do is we are going to have to regroup 1/4 so you can subtract it. So we are going to regroup this. And this means that we know that 7 plus 1/4 is 7 1/4, right? But what if we were to say that 7 1/4 is also equal to 6 plus 1 plus 1/4? That is true. And then we have this 1/1, which we could say is really 4/4. So 6 plus 4/4 plus 1/4. And then what we can do is we can add these fractions together with their common denominators, and we can get 6 5/4. And now we have a problem that we can work with because 5/4 is greater than 3/4. So now we have 6 5/4 minus 3/4. And we know that 5/4, you can take 3/4 away from 5/4. And so 5 minus 3 is 2/4. The 6 remains. 2/4 needs to be reduced to 1/2 because 2 and this is 4. I don't know if I have to do this for you guys, but 2 times 2 is what that is. So that becomes 1/2. And then that's our answer. Okay? So that's the second example for type 3. Type 4, let's go through. We're going to have your classic example of a mixed number minus a mixed number. So let's go through, I'd like to go through 2 examples of this as well, just because this can get a little tricky. Let's start with this example. Negative 2 7/12. Subtract 3 5/8. Okay. So what we need to do here is we need to turn our fractions into, well, we could start with the slash slash, so we're really adding a negative, and so that can be helpful. So we're really adding these two absolute values, and then the end result is going to be a negative, so something to remember. And so if we know that, if this is really just addition, we can ignore those negatives a little bit because we can add that at the end, because a negative plus a negative will always be a negative, or 0. Is that true? No, it'll always be a negative. So let's get some common denominators here. Okay, let's get some common denominators. So 12 is equal to 2 times 2 times 3. 8 is equal to 2 times 2 times 2. So we need to grab those 2 times 2 times 2, that 3, and we're going to get 24. Okay, so let's turn negative 7 twelfths. Wow. Negative 2 and 7 twelfths. 2. Negative, we'll multiply both by 2 to get the least common denominator, and we will get negative 2 and 14 24ths. Let's take this number, negative 3 and 5/8, and turn this into a common denominator. So we're going to multiply both of these by 3 to get negative 3 and 15 over 24. So now we have a problem that looks like this. Negative 2 and 14 24ths plus a negative 3 and 15 24ths. And so because we're adding them together, we can do negative 2 plus a negative 3, which is equal to negative 5. And then 14 24ths added to 15 24ths is going to give me negative 5 and 29 24ths. Now, just to provide a little bit more space for us, we would be converting negative 5 and 29 24ths into a fraction. We can't have 29 over 24 as an answer, so we have to turn this into an improper fraction, this part into this improper fraction into a mixed fraction, and then add the two parts. What's important to remember is that this, because it's negative, the overall thing is negative, this improper fraction is also negative. Okay, so what this means is that when I do this division, 24 into 29, I have to remember that my end result will also be negative. So 24 goes into 29 one time, giving us 5 24ths. So that means, I'm sorry, this is so sloppy, I'm not quite sure what's going on. What that means is I'm adding negative 5 to a negative 1 and 5 24ths, which is really negative 6 and 5 24ths. 4 and 1/3 minus 3 and 2/3. Again, to do this, we would regroup the 1/3 because 1/3 can't really take 2/3 away. So we will say 4 and 1/3 is really equal to 3 plus 1 plus 1/3, which is really equal to 3 plus 3 over 3 plus 1/3, which is really equal to 3 and 4/3. So then we have the problem 3 and 4, 4/3. Subtract 3 and 2/3. 3 minus 3 is 0, but 4/3 minus 2/3 is 2/3, and there's no reducing necessary, and that would be my answer. Okay, thank you, and work on practice, practice, practice. Check your answers as you go through, though, because these can get tricky with the negatives and the positives. Have a great time doing your homework.